Right, in this question, this is part C of a three-part question. And the previous question, we found this result here. We found that the integral of all of that using partial fractions equals this, and it's plus C. And noting that, we've got to realise that actually we've got to be looking for something to do with that in part C. Otherwise, there's no point attaching these to this question. It'll be a totally different question, separate question. So bearing that in mind, we need to get this on the bottom, and we need to get the 5 on the top. That will be a starting point. You need to be looking to integrate that. If you've got the 5 and you've got the same numbers on the bottom, especially spot the same brackets on the bottom as you did in the previous question, you've got to realise that you're going to use the same ideas. Now anyway, let's just follow the rules of differential equations. Remember, whatever's the top in your dy by dx, if it's dt by dv or whatever it is, whatever the variable is at the top, you've got to get that variable on the same side, and whatever's on the bottom you've got to get on the other side. You've got to separate them like that, and we'll see why in a minute. So bearing that in mind, I'm going to get all the x's on the right and get all the y's on the left. To do that, I'll need to divide by all the x's. So this is going to imply that dy by dx will equal 5y over x minus 1 times 3x plus 2. Now normally you'd just divide throughout by 5y probably, or maybe in just the y. But bearing in mind we want the 5 on the top here, we're going to just divide by the y to leave the 5 here. So that will give us 1 over y times dy by dx equals 5 over x minus 1 times 3x plus 2. And now we can integrate both sides with respect to x. So integrate both sides with respect to x. I'm going to show how you put it in here as an extra piece of working here. And what you'll see is, well, this is just going to end up with just the integral of 1 over y dy. And this obviously is going to be the same as what we found earlier. We've got this already worked out, so we don't need to work it out again. So let's just write it down. What the answer is, natural log of x minus 1 minus the natural log of 3x plus 2 plus a constant. And we want to write this out, work this out. So in 1 over y just comes from, it's a standard one, it's just natural log of y. Now what I'm going to do at this stage, I'm going to combine these two. Because I want to get y equals f of x, so I need to undo the natural logs, so I need to get all the natural logs together. So when you're subtracting natural logs, what you need to do is you divide the things you're taking the log of. Now we're ready to undo the natural log of y to get y equals something. So we get y equals, by doing this, well, let's just, how do you undo the natural logs? You raise it as a power of e, and you've got to raise the whole of this side as a power of e, and this is where people make mistakes. Often just leave the plus c down here, but actually the plus c is also a power of e. So you've just got y here equals, now we need to separate the plus c before we can do the same on this side. So you get natural log of x minus 1, 3x plus 2, and to separate the plus c, if you're adding indices, remember it's the same as timesing by e to that power. So now we're ready for this to all come down. Now e to c, what I'm going to do is I'm just going to call e to c, I know, k. So replace that, it's nicer. And e to the natural log of all of that is just all of that. So I get y equals x minus 1 over 3x plus 2 times k. Now we're given original conditions. Y equals 8 when x equals 2. So let's put that in. Y equals 8 when x equals 2. So we've got 8 equals 1, 2 times 3 is 6 over 8 times k. So therefore k equals 64. So my final answer is y equals 64, open brackets, x minus 1 all over 3x plus 2. Because k is 64.